This lesson is tessellations, and it ties in with SOLG.10. Identify tessellations in art, construction, and nature. A tessellation is best described as like tiling a floor. You've got different shapes of tile on a floor, and everywhere there's an intersection of tiles, you have a full circle of angles there. And the key number to remember with tessellations is that for the full circle of angles, you need 360 degrees. So at each intersection, you'll have 360 degrees worth of angles. Tessellation is a design or pattern in which a shape is used repeatedly to cover a plane with no gaps, overlaps, or empty spaces. A regular tessellation is a pattern made with only one type of regular polygon. So it could be an equilateral triangle or a square or just any regular polygon that works, that all sides are congruent and all angles are congruent. And again, the sum of the measures surrounding a point or vertex must be 360 degrees. Only regular polygons that have an interior angle which is a factor of 360 will do a regular tessellation. Otherwise, it won't complete the full circle. And no regular polygon with more than 6 sides can be used in a regular tessellation. We will identify which of those polygons works as the lesson goes on. So let's try some examples. Can these figures form a regular tessellation? As we talk about these figures, you need to remember about the interior angles of a polygon. And as we talk here, we'll remember that the sum of the interior angles of a regular polygon is 180 times n minus 2, and then one interior angle is simply 180 times n minus 2 divided by n. So that's what we'll be using to find one interior angle. And if that one interior angle is a factor of 360, then it will do a regular tessellation. How about an octagon? Well, if you do 180 times 8 minus 2 divided by 8, you get 135 degrees. And 135 is not a factor of 360. When you do 360 divided by 135, you get a decimal. It has to divide evenly in order to be the factor of 360. How about a square? Well, 180 times 4 minus 2 divided by 4 is 90, and 90 is a factor of 360, so that's a yes. You can do a regular tessellation with a square. 90 is a factor of 360 because 360 divided by 90 is 4, so it divides evenly. How about a regular hexagon? 180 times 6 minus 2 divided by 6 is 120 degrees. And 120 is a factor of 360, so yes, that can do a regular tessellation. 360 divided by 120 is 3, so it divides evenly, so that one works. Do 180 times n minus 2 divided by n. And if that will give you one interior angle. And if that number is a factor of 360, then it will do a regular tessellation. How about an equilateral triangle? 180 times 3 minus 2 divided by 3 is 60 degrees. So one interior angle of a regular triangle is 60. And 60 is a factor of 360. So yes, you can do a regular tessellation. 360 divided by 60 is 6. It divides evenly, so it works. How about this trapezoid? Well, I know immediately that it's a no, because this isn't a regular polygon. The sides are definitely not congruent, not all of them anyway, and the angles are definitely not congruent. You have acute angles up here at the top, obtuses at the bottom. This is not a regular polygon, so it doesn't do a regular tessellation. However, it will tessellate in another fashion, just not a regular tessellation. You can tile a floor with a trapezoid. It just won't be a regular tessellation. How about a rectangle? Well, I can see in the rectangle that it's not a regular polygon either. The, the angles are all the same. However, you have some sides that are shorter than the others. So this is a no because it's not a regular polygon. You can tile a floor with rectangles, so it will tessellate. It just won't be a regular tessellation. Remember, to be a regular tessellation, it has to be a regular polygon, and each interior angle has to be a factor of 360. Remember, to find one interior angle of a regular polygon, do 180 times n minus 2 divided by n. N is the number of sides. If that number is a factor of 360, then it will do a regular tessellation. A few final thoughts on tessellations. Remember, at each vertex of a tessellation, the sum of the measures of the angles must equal 360. That gives you the full circle of angles. If it's over 360, then that means there's overlap. If it's under 360, it means there's an empty space. It has to equal 360 to perfectly tile the floor. Any quadrilateral will tessellate. That's an interesting property of quadrilaterals. It might not be a regular tessellation. If it's a square, it will be a regular tessellation. But any quadrilateral will tessellate. You can use combinations of figures to do a tessellation. You can do a tessellation with octagons and squares, for example. You could do a tessellation with hexagons and triangles. There's lots of different combinations you can use, as long as each vertex has all of the angles adding up to exactly 360. And here's the final list, which you saw these in the examples we did. The only polygons that will do a regular tessellation are equilateral triangles, squares, and regular hexagons. Those will do a regular tessellation. Other polygons might do some other form of tessellation, but these are the only ones that do a regular tessellation. If you just think, can you tile the floor with it? That, I think, is the best way to understand tessellations.